A new space startup emerged from stealth in early July 2026. The company is called Lunar, and their plan is to use lunar soil for building infrastructure on the moon. Specifically, the company plans on using autonomous laser sintering to fuse lunar soil, or regolith as it's called, into structural material suitable to surround lunar nuclear reactors. NASA and the Department of Energy are targeting a fission surface power demonstration on the moon by 2030. Initial systems could be in the 40 kilowatt range, later scaling up to 100 kilowatts or more. As the Artemis base expands, and especially with the start of commercial resource processing, multiple reactors would likely be required to provide reliable baseload power. Lunar's approach is to manufacture the heavy infrastructure around the reactor on the moon rather than launching it from Earth. The nuclear core itself is relatively compact. NASA's 2018 Krusty demonstration, for example, produced 1 kilowatt from a uranium core weighing just 28 kilos. While larger reactors will have greater core mass, the structural containment, radiation shielding, and thermal management systems dominate the overall mass budget. Building these on-site using in-situ resources could dramatically reduce launch costs. Lunar has raised $7 million in a pre-seed round and estimates an additional $160 million will be needed over the next 3 years. The key technology: mobile autonomous laser sintering. The core of Lunar's approach is mobile autonomous laser sintering, using a laser to fuse lunar regolith into usable structural material without the need for imported binders. Here is how the process works. A mobile system first collects regolith from the lunar surface. It then prepares the feedstock by filtering and sieving to achieve consistent particle size. The system can survey the terrain and adapt in real time to variations in regolith composition and properties, a capability the company highlights as a key technical differentiator. Once prepared, the regolith is sintered layer by layer into dense, high-strength components, capable of withstanding the moon's extreme thermal swings and radiation environment. This material is well suited to forming containment structures and radiation shielding around nuclear reactors. It could also provide protection from solar radiation, which due to the lack of meaningful atmosphere is dangerous, and in the case of a solar flare, could prove deadly to humans. The autonomous system can deploy these containment structures in place, using local resources, requiring only an energy source. Early versions will use solar power and batteries as a power source. Later versions will use a radioisotope power source for continuous day and night operation. The company also has described an AI-coordinated hive mind approach, in which multiple units work together on larger structures. While the initial focus is on reactor infrastructure, Lunar intends to apply the same sintering platform to other surface construction tasks, including landing pads, berms, blast shields, and structural foundations. Execution is the moat. According to the company, the science is well understood. What matters is execution. Laser sintering on lunar regolith has already been demonstrated under relevant conditions. Researchers at the German Aerospace Center and Laser Zentrum Hanover have shown how the process works on lunar simulant material. Laboratory samples produced using this technique have achieved compressive strength exceeding 200 megapascals, with some reaching 345 megapascals. For comparison, ordinary concrete typically reaches only 20 to 30 megapascals. Lunar is simply turning a laser sintering system into a commercial product. Challenges: operating on the moon is difficult, especially when systems must interact directly with the lunar surface. Unlike Earth soil, which has been weathered over time, lunar regolith is sharp, abrasive, and electrostatically charged. The Apollo rovers experienced this problem firsthand. Dust repeatedly clogged their thermal exhaust vents, raising the risk of overheating. Lunar Forge will have to show they can operate continuously in this dusty environment without their mobile systems becoming degraded or non-functional over time. Extreme temperature swings between lunar day and night add another layer of difficulty. Repeated expansion and contraction of components could lead to mechanical stress and eventual failures if not properly managed. Radiation exposure is also a concern. Without an atmosphere or magnetic field to provide protection, galactic cosmic rays and solar particle events can degrade electronic and optical components over time, unless appropriate shielding or hardening measures are added. Is Lunar Forge's narrow focus wise? The company has chosen a very narrow focus, producing structural containment and infrastructure specifically for lunar nuclear reactors. While this allows them to optimize their processes for a technically demanding task, it does appear to limit their addressable market. In the near term, their primary customers would be NASA, the Department of Energy, and the prime contractors developing fission surface power systems. It's worth questioning whether this is the wisest approach, particularly because nuclear reactors are not essential for the earliest phases of a lunar base. Initial Artemis landings and short-duration missions can rely on solar power, supplemented by batteries or radioisotope systems. Fission becomes more relevant for sustained operations and large-scale activities later in the decade. Even then, the total number of reactors deployed to the Moon may remain small, at least initially. A single demonstration reactor, or perhaps a handful rated at 40 to 100 kilowatts or more, could meet early needs. This raises a practical question. What does Lunar Forge do once it has supplied infrastructure for those first units? There are already several companies developing more general-purpose lunar infrastructure capabilities. These include Astroport and Ethos Space Resources, working on regolith processing, Icon on construction systems, and larger players such as Blue Origin and SpaceX with broader lunar ambitions. By specializing so tightly on a niche tied to nuclear reactor deployment, Lunar Forge could find itself competing against organizations with wider customer bases. What happens if nuclear reactor deployment is delayed until the mid-2030s? How does the company make money? A different administration may pivot away from lunar nuclear reactors, as they are not essential even for a substantial moon base. My take is that the company is taking a high-risk approach while the reward doesn't appear to be that substantial. A more balanced approach to lunar infrastructure construction would give the company more potential customers. For instance, a large moon base requires multiple landing pads, blast shields, berms, kilometers of roads, plus site preparation for surface assets. In short, Lunar Forge is taking a high-risk path. The technical focus is understandable, but the commercial reward would be less than a broader infrastructure play could offer. Upcoming events. Lunar Forge plans to conduct its first lunar demonstration mission in 2027. This will test the technology on real lunar regolith under the vacuum and reduced gravity conditions of the Moon's surface. Follow-on missions are expected to upgrade the power system from solar and batteries to a radioisotope source for continuous day and night operation, eventually progressing to multiple AI-powered units working together. The company aims to be ready to manufacture nuclear reactor shielding and infrastructure on the Moon by 2030, supporting NASA's target for efficient surface power demonstration under the Artemis program. The same autonomous Sintering platform is also intended to contribute to broader lunar surface needs as the base and commercial activities expand. What do you think of using laser sintering to produce structural containment vessels and robust infrastructure on the Moon? Let me know your thoughts and opinions in the comments below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.